Okay, so the Fisher projection for this first one is pretty simple. Since it's just a triose, I've only got 3 carbons, right? And the ose means what? Okay. And aldo? Aldehyde. And it didn't specify as L or D, but what would this one be?
D.
D. Okay. So ketopentose. So 5 carbons with this one. And so C. There's a couple of ways you could do this, but I'll just. We good with that? Sometimes the carbon will be drawn here instead of not drawn here, the aldehyde. And this one would be what? L or D? L. Okay. Above 2 questions, L or D, explain the chemistry. So this guy here is a D because it's on the right-hand side. And this one here is an L because it's on the left-hand side. And what's particular about this carbon here and this carbon here? Not that it's second from terminal. Last chiral. It's the last chiral one.
Could you have just drawn the LH on the other side? Like, I'm not.
Where?
Well, it seems like. Can the LH when it says.
Do you mean over
drawn-
here?
What?
Over there?
Yeah, like
No.
could it have been drawn?
Oh,
It
I'm
says
sorry.
just
For number
draw-
2?
Yeah, if it
Yeah.
doesn't say L or D, you can just. put
Yeah, I
it
didn't
on
say that
either
it needed to
side.
be. I didn't care.
Oh, so like, if we drew it on the other side, we just would call it D.
Yes.
Oh. Just make sure I put it on the other side.
Okay. Then it's the other one. Doesn't matter. What are the 3 common disaccharides? Sucrose, lactose, and maltose. So this is glucose, glucose plus fructose plus galactose plus glucose. So they all have glucose in them. Maltose is double glucose, and then the other 2 are fructose and galactose. All right. Draw D, L, and D. All right, so. And CH2OH. 4, 5, 6. H2OH. And CH2OH. And where do I put the OHs? So we can go, let's do the L, D, and L thing first. So it's OH here, and an OH here, and an OH here. And where are they with relationship to the glucose? Carbon number 2. What side?
D
No, carbon number 2.
on the first one?
Yep, on the glucose. I don't know. I just thought you guys had had it. I don't expect it to be memorized. Right. And this one?
Oh, yeah, that's
Left. And this one?
Right.
Right.
right. Mhm.
And so, how does galactose differ?
The OH is on the left, sorry, on the bottom.
Which carbon? The top one's number 1.
The top one's the one,
Always. Carbon number 1's always the top one because that's where the functional group is.
so that would be on the left side one.
The fourth one or something.
Would be 1, 2, third one there. Oh, you're looking,
And the fructose? Okay. So, what's the difference between the galactose and the glucose? That's it, right? That carbon's been flip-flopped. That carbon's hydroxyl group has been flip-flopped. That makes it a different substance. And besides that, they're both aldohexoses. And then the fructose is completely different because it's ketohexose, right? So its structure is going to be significantly different than the other twos. All right. Monosaccharides, what's their main function?
metabolism.
Okay. And the disaccharides?
Transport monosaccharide.
And the last one?
To the plants. Structures of the plants. Storage.
Why are the mono and disaccharides soluble? What makes them soluble?
The hydroxyl groups attached to the carbon chain.
Yeah.
Yeah, there are a lot of hydroxyl groups, right? So every single carbon's pretty much got an OH on it, or an oxygen in some fashion. So since every single carbon has an oxygen on it, that allows you to have something to be very soluble. So plentiful hydroxides make this thing soluble.